Hello, welcome to this session. In this lesson, we are looking at algebraic expression. So, algebra dates back 4,000 years ago. We can look at this in the Egyptians and Babylonian times. It was extended by the Alexandrian mathematicians Hero and Diophantus. It was doing the work of Arithmetica by Diophantus, which contained much higher powered algebra, including solution to some very difficult equations. Algebra, as we see today, is used in many aspects of our lives: aviation, business, science. So you can say to the fact that algebra is needed in every aspect of our lives. When we talk of algebra, we mean representing numbers with letters known as variables. We use algebra to construct mathematical expressions, formula that describe problem solving situations. Let's consider area of a rectangle. You can see the area of rectangle is obtained by multiplying the length by the width. In algebra, we write that the area A is equal to length times breadth, where the A is the area, the L is the length, and W is the width. The letters are known as variables or unknown. So instead of writing the expression in English, we use algebra. Likewise, instead of writing the perimeter of rectangle as the perimeter of rectangle can be found as twice of the length to twice of width, we simply write P is equal to 2L plus 2W. This English has been represented by an algebra. So you can say that algebra help us to represent situations in symbols or letters. So what is an algebraic expression? An algebraic expression is the form of algebra with variables and operational symbols. So any expression with variables or letters unknown and operational symbols. Let's see, check example. A plus B is algebraic expression. 2x plus 2y is also an algebraic expression. AB is algebraic expression because A is multiplying B. They are all algebraic expressions. So we have to look at operations of algebraic expression. So we are looking at addition and subtraction of algebraic expression. Let us consider this expression. AB plus 2BC minus 8AB minus 6BC. We are given this to simplify. To simplify this, we check the like terms. So the like terms are the variables which are the same. So we look for the likeness of AB and BC. We group the like terms. So when we group, we get, so AB will be grouped to minus 8AB. 2BC will be grouped to minus 6BC. So our next step is to simplify by performing the operations. So if you look at A minus 8AB, So it's like 1 minus 8, which will get negative 7ab. 2bc minus 6bc will give us minus 4abc. So we get minus 7ab minus 4bc. So we perform operation on coefficients. So when we are adding or subtracting, we deal with the coefficients, then we write the variables or the letters. So mostly the coefficients are the ones that we subtract or add. Good. So we now check more examples. So we look at another example, which is 3x squared y squared plus 5x squared y minus x squared y squared minus 3x squared y. So what you need to do is to group like terms, that is the terms containing x squared y squared and x squared y. So we can see that 3x squared y squared is having likeness with minus x squared y squared. Then 5x squared is also having likeness with 3x squared y. So we now group them, so it will be 3x squared y squared minus x squared y squared plus 5x squared y minus 3x squared y. So when you perform the operation, that is 3 minus 1, you get 2x squared y squared. Then 5 minus 3, we get 2. Then we add x squared y. So we get 3x squared y squared plus 2x squared y. We perform the operations on the coefficients. So you have to look at that one always. You have to look at your integers. Good. So we then move on to other operations. So we are still under addition and subtraction, but here we are looking at algebraic fraction. So let us consider this. 2ab minus 4 over or minus b, 2a minus b over 4 plus a minus 2ab over 3. And this kind of expression is fraction. So what we do is that we simplify this the same way we solve fractions. So we look at the denominator, which is 4 and 3. Then we find the LCM. So the LCM of 4 and 3 is 12. Then what we do is that we will just 4 goes into 12 to be 3. So 3 will multiply the numerator of the fraction, which is 3 times 2a minus b. Then we also do the same to what the other one, which is the 3. So 3 goes to 12 to give us 4. So 4 times a minus 2b. So when we expand to this 2 will multiply 3 will multiply 2a. Then the same 3 will multiply minus b. So here 4 will multiply a, then 4 will come and multiply minus 2b all over 12. So let's start. When 3 multiplies 2a, we get 6a. 3 multiplying minus b, we get minus 3b. 4 times a, we get 4a. Then 4 times minus 2, we get minus 8b all over 12. So we now group like terms. So 6a will be marked to 4a, minus 3b will be marked to 8b. So it will be 6 plus 4a minus 3b minus 8. So we'll get 10a minus 11b over 12, because 6 plus 4 is 10, minus 3 minus 8 will give us negative 11. So our job is to do more examples so that we'll understand them. Let's move on to multiplication of algebraic expression. So if you consider these expressions, s times x is s squared, then a times ab is a squared b, 3xy times 4xy, we get 12s squared y squared. So what we can say is that when we are multiplying with the same variables, we use indices. So you see here it's having a power of 1, power of 1. So the power will be 2. But when they have the same base and they are multiplying, we add the powers. Here we have a. So the power is 1, power is 1, making the power of 2. Here too, we have the same thing, xy, xy. So each one will add together, we get 2. So we have to multiply coefficient, then we multiply variables, then we apply the laws of indices to on the like variables, then we add them. So let's also consider these things. You're asked to expand 2a bracket close ab minus b. So to solve this, 2a times ab, making 2a squared b. Then 2a times b minus b, we get 2 minus 2ab. So 2a times ab will give us 2a squared b. Then 2a times minus b will give us 2a minus b. So the whole expression becomes 2a squared b minus 2ab. Another one, 2x times x minus y bracket close. So this one outside will multiply this. Then this one also come and multiply this. This one will multiply this. And the same thing will multiply this. So when we expand 2x times 3x, we give us 6x squared. 2x times minus y to be minus 2sy minus 4x times 6x will give us minus 24x squared. Then 4x times minus 3y to be positive or negative negative, positive 12xy. So what we get is that. Then when we have 6x squared minus 24x squared, 2xy plus 12x squared, this is a group like terms. So this will be marked to this will be marked to that. So when you simplify, we get minus 18x squared plus 10xy. Then we move on to expansion of two binomials. So we have two expressions that we want to expand. That is x minus y times x plus y. So what we need to do is that we will just distribute first variables to the second variable. So we expand x minus y times x plus y bracket close by distributing the expressions. So if we have x minus y bracket close times x plus y bracket close, so it will be x, which is the first variable here, we'll use to multiply this. After that, minus y will be used to multiply this. So let's take s is multiplying here, the expression is here. Minus y is multiplying the same s plus y is here. So we start x times x will give us s squared. S times y will give us xy. Minus y times x will give us negative sy. The minus y times y will give us minus y squared. So we will get s squared plus xy minus xy minus y squared. So you see that this positive xy and negative xy will go to be 0. Then we get x squared minus y squared. So let's still take more examples under this. Therefore, anytime we are expanding two binomials of the same variables but positive and negative operation signs, this kind of expression is called differences of two squares. So we just take the expression with negative sign and square them. So let's look at this example. We have x minus y, x plus y. We can see that x is here, x is there, y is here, y is here. The only difference is negative and positive sign. So what we need to do is that we take the one with the negative sign, then we square the x, the first number, we square the second number. So it will be x squared minus y squared. Another example, 3x minus y bracket close, 3x plus y into bracket. So what when you want to multiply this, you see that 3x is here, 3x is there, minus y is here, y is here. The only difference is negative and positive. So it's difference of two squares. So you take this and square. So 3x square minus y square. 3x square will be 9x square. Then minus y square, we are done. Because this square will affect the 3, making 9. Then it will affect the x, making a square. Let's still make more examples here. So let's consider an expression again to expand. Expand and simplify a plus b all squared. So to expand this, we can just this s plus b square means it will be this a plus b square means a plus b times a plus b. So when you do the distribution, this one will multiply a plus b. Then this same b will come and multiply the same a plus b, as we have seen here. So a multiplying a plus b multiplying a plus b. So when we expand that, a times a is give you a square. A times b will give us ab. Then b times a will give us ab. Then b times b will give us b square. So when we arrange a square, ab, ab, they are 2ab, then b square. So this one become a rule. When we have two variables they want to square, we are to we will always get a square, which is the first square, plus 2 times first and second, then the last item square. So we can generalize this one, then we will always use a square plus 2ab plus b square. So it becomes like a rule that we will use to expand our expansions. So let's see, look at this example. So to do that square, the first variable with the coefficient, we square them. So if you want to do this, we square the first variable in that expansion we want to do. Then we multiply 2 times the first and the second variables. Then we square the last variable. Let's consider 2x minus 3y all square. So the first variable with the coefficient is 2x. The second variable with the coefficient is minus 3y. So the rule 2x minus 3y square. First square the first one, which is 2x square. Then 2 times the first, which is 2x and minus 3y. Then the last one, which is minus 3y square. So 2x square will be 4x square. Then 2 times 2x times minus 3y will give us minus 12xy. Then negative 3y square will give us plus 9y square. So you get 4x squared minus 12xy plus 9y squared. Good. So let's now move on to stop behind that. So let's consider the expansion in the expression a plus b all multiplying c plus d plus e bracket close. So we are multiplying this. What we do is that we distribute either the first one or second one each other. So we are distributing the second one. So C on this, then D will multiply the same thing, then E will multiply. So let's see. C is multiplying A plus B, D is multiplying A plus B, E is multiplying A plus B. So let's go. So A times C is AC, C times B is CB, CB is here will be CAAC. Then come to this side. Then D times A will be AD. Then D times B will be D BD. Then E will multiply this. That is EA. Then the same E will multiply B EB. So here C times A, which is AC. Then here C times B will be CB, CB, BCB. Then D times A will be AD. Then D times B will be BD. E times A will be EA. Then E times B will be EB. So when you get an expression like this, what you do is that you use this one to multiply all of this. Then use the D to multiply all of this. Then use this to multiply all of this. So let's look at few examples. Now we have example here. We have x plus 3 is multiplying x squared plus 2x plus 4, all of them. So we take x squared, we use it to multiply x plus 3. Then you take 2x, we use to multiply all of x plus 3. We take 4, it will multiply x plus 3. So let's see. So it's x squared times x plus 3. So 2x times bracket close x plus 3. 4 times x plus 3 bracket close. So we start x times x, x squared times x is x cubed. X squared times 3 is 3x. Then we come here 2x times x is 2x squared. 2x times 3 is 6x. Then we come here 4 times x is 4x. 4 times 3 is 12. So now we group like terms. When you group like terms, this x cube is not having any like term, then you just write x cube. 3x squared is having a like term with 2x squared. So we added 3 plus 2 will be 5x squared. Then 6x and 4x, so we give you 10x. Then you just write the 12. So this helps us to know how to expand expression like that. So we are moving on to factorization. How to factorize a given expression. So algebraic expansions and expressions are mostly product of variables. To factorize this expression means splitting the expressions or the expansion by getting the common variables or terms. Usually we use HCF, highest common factor. A factor is a term. Factor is a term which is common in both expression or terms. So consider the expression 3 times x plus 2 bracket close. So 3 times x will give you 3x. 3 times 2 will give you 6. So the expansion of 3 times x plus 2 is 3x plus 6. The factorization of 3x plus 6 is 3 times x plus 2. So you can see that factorization is the reverse process of expansion. When we expand, we get the expression. When we factorize, we get another expression. So factorization is therefore the process of writing expression as a product of its factors. And in expansion, we remove brackets, and in factorization, we insert brackets. So let's take few steps and examples. To factorize any expression, we first find the common factors and collect them outside the bracket. We divide each of the terms by the common factors and arrange or group the terms. So let's consider a square b minus ab square. We are asked to factorize this. So what you see is that a is common here, is common there. So a is here, a is here, b is there, b is there. So you take the factor. So the factor will be ab. So then the remaining one will be a minus b. So to get the common factors of a square minus a square b minus a b square, it is ab. So to get the other terms, what you do is that you use the term which is a square b over ab, the factor. Then this ab will cancel one of it, getting we get what? B. We get b because the b you get a, the b will cancel b, then the a will cancel one of this a, making a. Then the same way a b square over ab. So a will cancel a, then b will cancel one of this b, making b. So that's why we have ab, a minus b. So when we want to factorize, we get the common items out. Get the common items out. Then we use the factors to divide to get the other one. Let's take examples of a lot of them to get more understanding. So now, suppose we have this to factorize x minus 1, x plus 2, 3 times x minus 1. So if you look at this expression, x minus 1, bracket close, x plus 2, bracket close, 3 times bracket close, x minus 1. So you see that x minus 1 is here, x minus 1 is here. So the common factor will be x minus 1 will be the first that we correct. The remaining ones are x plus 2, then 3 times x minus 1. So don't expand. So you see that x minus 1 is here, x minus 1 is here. So you just pick x minus 1. What are the rest remaining? So it will be x plus 2 plus 3. So x plus 2 plus 3. So it will be x minus 1. So x plus 2 plus 3. 2 is like term of 3. So 2 plus 3. So get x minus 1 times x plus 5. That will give you the expansion. So if you get something like that, don't get scared. Just move on and do your work. Let's still check another factorization, which is another one, another example here. So in this example, m is outside the bracket multiplying m minus 7 bracket close minus 2 outside bracket m minus 7 bracket close times m plus 1. So we write or m minus 1 bracket close minus 2 times bracket m minus 7, then bracket into bracket m plus 1. So if you check it, m minus 7 is here, m minus 7 is there. So HCF will be m minus 7. So we get m minus 7 out, which is here. Then the remaining ones are the m minus 2 and m plus 1. M minus 2 and m plus 1. Then we are done. M minus 2, because m is here, it will map to this minus 2, then m plus 1. Then we are done with factorization. So you look for the common one, the one which is both sides. So m minus 1 is minus 7 is here, m minus 7 is here. So we take m minus 7. Then this m will now be grouped to m 2 minus 2. Then m plus 1 will just come there. So there's another factorization that we'll consider, which is difference of two squares. Consider this expansion that we did, s minus 1 or brackets times s plus y or bracket, s minus y bracket close times s plus y. So we said you square x square y. So you take this one, then you square both of them. This is called difference of two squares. Now, suppose you have been given this to factorize. What should you do? Given s square minus y square to factorize. S square minus y square, we simply write the difference of two squares. So it will be s minus y times s plus y. The same way, if you're asked to factorize 9s square minus 16y square. So given this, we have to express this in terms of squares. So you see that we can write 9 as 3 square. Then you can write the s is already a square. You can write 16 as 4 square, and the y is already square. So you can group them. This one, you can write it as 3x square bracket close. And you can write this as 4y square bracket close. So you see that they are square, square, negative. So you just repeat them, 3x plus 4y bracket close, 3s plus 4y. So you are done. That's the difference of two squares. So here, when you see this thing, you just write it 3s plus 4y, 3s minus 4y. So any variable that you get, you just do it that way. Then it will be done. Okay, let's now move on to groupings and algebraic expression. Suppose when we were having two expression like this, 2p plus q, a minus b, we expanded and we had something like this. So this one will multiply this, which will be 2ap. This same thing will come and multiply this, which will be 2 minus 2 bp, and so forth and so forth. So we'll add this as the final product. Now, to factorize the expression like this one, what are we going to do? So factorize 2ap expression like this. We first group the expression. So we group them. So we put bracket here, you put bracket there, then come and put bracket there. So note that when you're putting the bracket, if the negative sign is here, the sign inside the bracket will change. So you put bracket here, you put another bracket there. But here, putting the bracket here is negative. So the sign here will change to the opposite, which is positive. That's why we have it there. That is how we group them. So let's see how we will solve such expression. So after we have grouped them, we now take the common terms out. So we have grouped them here like this. So we now 2AP plus AQ. So you see that A is there, A is here. So A is common term. I have pick. So if you take 2AP, if you take the A out, what do you get? 2P. AQ, if you take A out, you get Q. Then write it. Then here too, see B is here, B is here. So B is the common number, write it. So BQ, if you take B out, remaining Q. Then here 2BP, if you take B out, get 2P. So we now see that this one is exactly the same as this. So write one of it, which will be 2P plus Q. 2P plus Q will be the common one. 2P plus Q. Then the other one will be A minus B. Let's look at how we do it. So having factorized it, this one, you arrange based on the letters alphabet. So A, 2P plus Q bracket close minus B, 2P plus Q bracket close. So you see that this 2PQ, 2PQ are also common to both sides. So you see that it's common, it's here, it's also there. So the factor is 2P plus Q. So you bring 2P plus Q first, then you now bring A minus B to the next one. We have actually factorized. So when we are factorizing, we group. After grouping, you select the common terms out. Then you still group them based on what is on both sides. So let's take our final example. Suppose we have mx plus ns plus my plus ny to factorize. So here we put brackets here for grouping. Then put bracket there for groupings, as you can see here. So we see that ms, nx, x is common in both sides. We pick s out. So here ms, if s goes to be m, ns if s goes to be n, so it's m plus n. So my, ny, y is common. We bring the y out. My if you take y to be m, ny if you take y to be y, to be n. So you see that m plus n is both sides. So you bring m plus n out, then the remaining s plus y be selected out. So you have actually factorized. Let's look at the last one, which is mn plus 3p plus np plus 3m. So you write it this way, then you put brackets, you group them. So after this grouping, this is the grouping as you see. So you see that m is there, m is here. So m is with the common term here. So if if you take m out, you get n. Then here you m 3m, if you take m out to be 3. Then this one to 3p here, np, which one is common is p. 3p if you take p out to be 3, np if you take p out to be n. So you see that 3 n plus 3 is common to both sides. So you bring that one first, then write the remaining numbers into the bracket or remaining letters to the bracket. So thank you. We will still continue. You have to solve more examples so that you understand what we are doing.